Answer for homework 8, question 2. So the question reads that n is a Poisson process with parameter lambda, which is to say that the probability of n, which is the number of random points that are in T1, T2, which is equal to k, is equal to e to the negative lambda of T2 minus T1 times lambda times T2 minus T1 to the power of k over k factorial. And the stochastic process that we're given is that x of t is equal to 1 if n is odd in 0 to t, or negative 1 if n is even in 0 to t. And so this is a telegraph signal, and this is roughly what it looks like, where you have t on the horizontal axis and x of t on the vertical axis, and the signal is only ever 1 or negative 1. So the first part of the question asks us to find the probability that x of t is equal to 1, i.e. the probability that n is odd in 0 to t. So the probability that x of t is equal to 1 is the sum of all probabilities of when n is an odd number. So you have p1 plus p3 plus p5 until infinity, and so then that's equal to e to the negative lambda t. And then here you have this series, which is we have p of 1 is going to be equal to lambda t, and then e to the, where lambda is 1, so that's why you only end up with k is 1, which is why you only end up with lambda t. And then when k is 3, you have lambda t to the power of 3 over 3 factorial. And when k is 5, you have lambda t to the power of 5 over 5 factorial, all the way to infinity. And so then this is actually the Taylor series of the hyperbolic function of sine, which I'll probably call shine from now on. And that's, so altogether that's equal to e to the negative lambda t of shine of lambda t. And so alternatively, from the other side, if we were looking for the probability that x of t is equal to negative 1, this would be equal to e to the lambda t of cosh lambda t, or the hyperbolic function of cosine. So the second part of the question asks us to find the mean, or the expectation of x of t. So that's equal to the e to the negative lambda t of the upper limit minus lower limit, so that's shine of lambda t minus cosh lambda t. And when we write that out, so shine of lambda t is actually equal to e to the lambda t minus e to the negative lambda t over 2, and then cosh lambda t is equal to e to the lambda t plus e to the negative lambda t over 2. And so when you put those into the equation, you end up with, well, this is what it's like written all out, and then things cancel out, so you end up with e to the negative lambda t times e to the lambda t minus e to the negative lambda t, which is equal to 1 minus e to the negative 2 lambda t. And then part C, asks us to find the autocorrelation of T1, T2. So our T1, T2 is equal to e of x T1 times x T2, which is that, that's another way to write this is the probability that in T1, T2, k is even, minus the probability of T1, T2, k is odd, which we already found from the beginning of the question. So we have e to the negative lambda t cosh lambda t minus e to the negative lambda t shine lambda t. And so we sub in the same thing from the last question. So you have some stuff that cancels out here. So you end up with e to the negative lambda t times 2 e to the negative lambda t over 2. So the 2's canceled out, which just leaves us with e to the negative 2 lambda t, or e to the negative 2 lambda times the absolute value of t1 minus t2. And the last part of the question asks us if x of t is a wide-sense stationary process. We know that x of t cannot be a wide-sense stationary process because e of x of t and r t1, t2 are, they're not independent of t, so they actually do rely on time. And in a wide-sense stationary process, the e of x of t should only be a constant and not reliant on variables.